The wheel. Picture this. You need to move a 2-ton stone block across a desert. You have ropes, people, and sand. That stone is not moving anywhere fast. Moving it 100 meters takes 3 days and breaks people's backs. Then, someone picks up a log, puts it under the stone, and rolls it. Suddenly, the same stone glides across the ground like it weighs almost nothing. That is the wheel. A circle spinning around a rod. That is it. The most powerful shape in history is just a circle. Once people had wheels, everything changed. You could now move 10 times more stuff in a fraction of the time. Trade became real. Armies could carry supplies better. One person could do the work of 5. And civilizations that figured out the wheel just started dominating the ones that did not. Then it kept going. Potters used wheels to shape clay. Mills used wheels to grind grain. Chariots used wheels to win wars. The wheel became so important that ancient empires spent massive fortunes building roads. Rome did not build roads because they liked architecture. Roads were just wheel infrastructure. Remove the wheel, and Rome falls apart overnight. The lever. Now here is something that seems even simpler than a wheel. A stick. But not just any stick. A stick on a pivot point. That pivot is called a fulcrum, and when you place it correctly, something wild happens. You push down on one end of the stick, and the other end lifts something much heavier than you ever could on your own. That is the lever. And the magic inside it is called mechanical advantage. Here is a concrete example. Say you want to lift a stone that weighs 100 kilograms. You have a 5-meter wooden beam. You slide the fulcrum 1 meter away from the stone. That leaves you 4 meters of beam on your side to push down on. Mechanical advantage equals effort arm divided by load arm. So 4 divided by 1 equals 4. Your force gets multiplied by 4. So instead of lifting 100 kilograms, you only need to push with the force of 25 kilograms. Same stone. Same you. But the lever does most of the work. You are not stronger. Physics is just working for you now. Archimedes figured this out and said something that sounds insane, but is mathematically correct. He said, "Give me a lever long enough and I can move the entire Earth." He meant it literally. If the fulcrum were in the right place, the math works out. And this one principle became the backbone of almost every machine ever built. Scissors, wheelbarrows, catapults, carjacks. All of them are just levers wearing different clothes. The lever taught humans something that changed everything. You do not have to be stronger than nature. You just have to be smarter than it. The pulley. So the wheel changed how we move things sideways. The lever changed how we lift things. But what if you need to lift something straight up, repeatedly, without destroying your body? That is where the pulley comes in. Take a wheel. Hang a rope over it. Now when you pull down on one end of the rope, the other end goes up. The pulley just changes the direction of your force. That alone is useful. But here's where it gets interesting. Stack multiple pulleys together, and something else happens. You start dividing the load across multiple rope segments. 2 pulleys means you only need half the force to lift the same weight. 4 pulleys means a quarter of the force. Stack enough pulleys, and one person can lift something that normally requires a dozen people. Sailors called this setup a block and tackle. They used it to haul massive sails, anchors, and cargo onto ships. Construction crews used it to stack stones and towers. Mining operations used it to drag ore out of the ground. The pulley gave humans the ability to build upward. And once you can build up, civilization changes completely. You can see farther. You can defend better. You can fit more people into less space. Every great city in history sits near water, partly because pulleys made it possible to move water vertically. And water is everything. The mirror. For most of human history, you could not clearly see your own face. Water gave you a blurry reflection. Polished metal worked, but it was rare and expensive. Most people went through their entire lives without ever seeing themselves clearly. Then someone figured out that a smooth, flat, reflective surface bounces light back in a perfect copy of whatever is in front of it. A mirror. That sounds trivial. It was not. Mirrors changed how humans understood themselves. They became obsessed with them. But more importantly, mirrors unlocked optics. Once people understood how light bounces off surfaces, they started experimenting. What if you curve the surface? What if you angle 2 mirrors? What if you combine a mirror with glass? Those questions led directly to microscopes, telescopes, cameras, and eventually lasers. Every time you look at a photo, use a camera, or sit in a dentist's chair while they check your back teeth, you are using the descendant of a mirror. The mirror made self-awareness, something you could study instead of just feel. That shift sounds philosophical, but it had very real consequences for science. Glass. Here's a question. How do you let sunlight into a building without also letting in wind, rain, and freezing cold? For most of history, there was no good answer. You could hang cloth over a window, but that blocks the light. You could leave the window open, but then you freeze. Stone walls kept people warm, but made the inside dark. The answer turned out to be sitting in the ground the whole time. Sand. Heated to extreme temperatures until it melts, then cooled back down. The result is transparent, solid, and it does not let weather through. That is glass. Sand plus heat plus time. Windows changed what it meant to live in a building. Suddenly, you could have light and warmth at the same time. Entire cities became possible in climates that were previously too brutal to survive comfortably. Northern Europe built huge cities, partly because of glass windows, but glass did something else that mattered even more. When you shape glass into a curved lens, it bends light. And bent light can do things flat light cannot. It can magnify. It can focus. It can redirect beams from the sun to start a fire from across a room. Glass is why Venice became one of the most powerful cities in medieval Europe. The Venetians figured out glassmaking first and kept it a secret for centuries. They literally exiled their glassmakers to an island to prevent the knowledge from escaping. That is how valuable it was. The spring. Every machine has a problem. It needs energy exactly when you need it, not before, not after. Your muscles can do this, but muscles get tired. Machines need something that stores energy perfectly and releases it on demand. The spring solved this. A spring is just metal, shaped in a way that wants to return to its original form. Compress it, and it pushes back. Stretch it, and it pulls back. The energy is stored in the shape of the metal, waiting. Release it, and the energy comes out in a controlled, predictable burst. This sounds simple, but it was the missing piece for precision machinery. Watches needed springs. A coiled spring releases energy at exact intervals. Those intervals move gears. Those gears move hands on a clock face. Before the spring, timekeeping was rough and inconsistent. After the spring, you could measure time to the second. Guns needed springs to fire reliably. Locks needed springs to work. Engines needed springs to control valve timing. The Industrial Revolution did not happen because people discovered fire or metal. Those had been around forever. It happened because engineers figured out how to make machines reliable. You could not have a factory that broke down every hour. You needed machines that did the same thing, the same way, thousands of times in a row. Springs are what made machines trustworthy. And trustworthy machines are what made the modern world possible. The telescope. For all of human history, the night sky was a mystery. Stars were just lights. The moon was just a glowing circle. Nobody knew what was up there or how far away it was. Then someone figured out that two curved pieces of glass, arranged correctly, could make distant objects appear close. The first lens catches light from something far away and bends it inward. The second lens catches that bent light and bends it again, right into your eye. The result is that something a million meters away looks like it is a few meters away. Galileo did not invent the telescope. He just built one good enough to point at the sky. And what he saw cracked civilization open. The moon had craters and mountains. It was not a perfect smooth sphere. Jupiter had moons of its own, orbiting it, not Earth. Stars that were invisible to the naked eye turned out to be entire clusters. The sky was not a painted ceiling above a flat world. It was an infinite space full of objects. This was not just new information. It contradicted everything the most powerful institutions in the world were teaching. The Earth was not the center of everything. Humans were not the audience the universe was built around. People were put under house arrest for saying this. Books were banned. Ideas were suppressed. Two pieces of curved glass caused that much disruption just by showing people what was actually there. The clock. Here is something most people never think about. Before clocks, time was local. When the sun was highest in the sky in your city, it was noon for you. But 50 kilometers east, their noon was a few minutes different. Every city ran on its own version of time. This was fine when nothing needed to be coordinated. But once you have trains, it becomes a disaster. A train leaving one city and arriving in another cannot have a timetable if both cities disagree on what time it is. The clock fixed this. It divided time into equal, repeatable pieces that everyone could agree on. A pendulum swings at the same rate every time. A spring releases energy at a controlled pace. Gears break that motion down into hours, minutes, seconds. Everyone sets their clock to the same standard. Now time is real, objective, and shared. This changed trade. Factories could run shifts. Ships could coordinate at sea. Entire global systems of commerce became possible because humans finally agreed on a shared version of time. The British Empire pushed clock standardization across every territory it controlled. That was not just about scheduling. It was about control. When you control the time, you control coordination. And coordination is power. Look at what those 8 inventions actually are. A circle, a stick on a pivot, a wheel with a rope, melted sand, bent metal, 2 pieces of curved glass, a controlled pendulum. None of them required advanced technology. None of them required a genius. Most of them were figured out by people who were just trying to solve an annoying problem in front of them. The pattern is always the same. Someone noticed that the obvious solution was not working. They stopped, looked at the problem from a weird angle, and tried the simplest possible alternative. And somehow that simple thing broke everything open. We are still doing this right now. Somewhere, someone is staring at a problem that has bothered people for generations. They are about to try something so obvious, everyone else walked past it. When they do, we will all wonder why we did not see it first. So here's the question. Which of these 8 inventions do you think had the biggest impact on your daily life right now? Today? Not historically. Right now, in your routine. Drop your answer in the comments. And if the spring surprised you, stick around for the next one.